Okay, we're going to take a look at understanding multiplication of integers. We're going to start or finish up our unit. We've done adding and subtracting, so what does it mean to multiply and divide? So if you notice, we're going to use the version of the integer game again, and we're going to pretend like we've been playing in groups of 4, and we're going to do some things with the cards. So let's say that in your hand you receive a 3, a -2, a -5, and a +4. So go ahead and write that in. So what happens with the star is we're going to go ahead and use, that's going to tell us what we're going to copy or repeatedly add. So on the bottom here, we're going to keep our cards that we have, so the 3 and the -2 and the 4, but then the one with the star -5, we're going to multiply that, and we're just picking an arbitrary number. We're going to multiply it 3 times. So this particular card, we get to add it 3 times, so -5, -5, -5. So now that we have this, let's go ahead and answer the questions based on our hand. So the first thing it says, using your cards from Part B to answer the questions below, write the product that describes the 3 matching cards. Well, that would be, if product, remember product means multiplication. So the 3 matching cards, we have -5 or -5, and we have 3 of those. So we would write this as 3 times a -5. And again, we don't want signs being next to each other, so we're going to put the -5 in parentheses. Then it asks, write an expression that represents how each of the star cards changes your score. So we have added -5 3 times, so that would be -5 plus -5 plus -5. So that's how it changes our score. It is added -5 3 times. So write an equation that relates these 2 expressions. We're just going to show how these are equivalent. So 3 times a -5 is equal to what? Well, it'd be -5 plus -5 plus -5. Okay? Write an integer, okay, another vocabulary word, write an integer that represents the total change to your score by the 3 star cards. Well, it would be -15. We are changing our score by a value of -15. And then last but not least, write an equation that relates the product and how it affects your score. All right, well, that would be 3 times -15 or -5 is equal to -15. Okay? So that is the line of questioning based on our hand there. Right, so let's move on to the next page, or the back of this, I should say. And what we're going to do is we're going to come up with another hand. Let's say that our hand this time is, let me go back and find out what it is. Oh, here we go. Our new hand is going to be -1, 5, -3, and 4. And in this case, the 4, I'm not exactly sure why the star isn't there, but let's go ahead and put a star underneath the 4. So that is going to indicate what we're going to repeat. So for part D, we're going to copy down our numbers, -1, 5, -3, and then the 4 is going to get copied 1, 2, 3, 4, 5. Okay, so we have 5 of these. So again, answering the questions, you can go ahead and stop the video and see if you can answer questions F through J, or F through, well yeah, F through J. We'll just stop there. And then go ahead and restart the video and see if you got the same answers that I did. Right, so go ahead and try that on your own and then continue the video. All right. So what you should have, write a product that describes 5 matching cards. Well, there's 5 of them, so that would be 5 times 4. And what does this mean? What expression shows or represents how each of the star cards changes your score? Well, that would be 4 plus 4 plus 4 plus 4 plus 4. And then writing an equation that relates these two expressions. Well, 5 times 4 is equal to 4 plus 4 plus 4 plus 4 plus 4. Then write an integer that represents the total change in your score to the 3 cards, or by the 3 star cards. Actually, it should be by each of the star cards, and that is 20. The integer is 20. And then write an equation that relates the product and how it affects your score. Well, that would be 5 times 4 is equal to 20. All right, so go ahead and write a conclusion. We're on K and L. Go ahead and write a conclusion using the expression 5 times 4 to relate the multiplication of a positive valued card to addition. So kind of make a statement or observation of what happens with 5 times 4. All right, so how is that changing our value? How does that affect our score? So go ahead and answer that. And then do the same thing with L, using this expression 3 times minus 5 to relate the multiplication of a negative card value to addition. So relating multiplication to addition. Go ahead and try those two, and then continue the video to see how your answer matches up. All right, so for the first one, if we're going to multiply a positive integer card is repeated. Addition of the positive card. And what happens to our score? It will increase. So basically 5 times 4 is the same as 4 plus 4 plus 4 plus 4 plus 4, and that all equals 20. So each one of these expressions is equivalent. All right, what about the other situation, 3 times a negative 5? Well, multiply a negative integer card is repeated. Addition still, not subtraction. Of the negative card. And decreases your score. So we have 3 times a minus 5, which is minus 5 plus minus 5 plus minus 5, and that is equal to minus 15. All right. So now that we have our two observations of what is happening when we multiply positives and negatives, let's go on to the next example, which is example 2. So product of a negative card and a positive card. So if 3 times A represents putting 3 cards into the value A into your playing hand, what would minus 3 times A represent? All right, so let's see what happens. So we have a minus 5 and 3 4s. So the score decreases by 4, or if all the 4s from the playing hand are discarded, how will the score be affected? Model using a product in an equation. So if we take all 3 of these away, the score decreases by 4, and that is 3 consecutive times for a total of 12 points. So the equation would be, remember we're taking it away, so it's minus 3, since that's going to represent our discarding, times 4, because each card is 4, therefore we have decreased by 12 points. All right, what 3 matching cards could be added to those pictured to get the same change in score? So we're not taking away the 4s. This time we're going to add cards to it that's going to change our score. Well, if we can also add minus 4 3 times. So to get the same, or the same change in score, we would add 3 negative 4s. So the equation would be 3 times a negative 4, which is also negative 12. All right, so seeing how each play affects the score, relate the products that you use to model them. What do you conclude about multiplying integers with opposite signs? So if you look at part A, we took away 4 positive cards, but here we added 3 minus 4 cards. So how are those the same? Well, minus 3 times 4 is equal to 3 times minus 4. So what happens with either sign? Does it matter whether we have minus 3 times positive 4 or 3 times a minus 4? Well, it doesn't, because adding a value multiple times has the same effect as removing the opposite value the same number of times. Okay. All right, so we do know that 3 times a negative number and a negative number times a positive number are going to be the same thing. So let's take a look at our example 3. If the matching cards from the playing hand on the right are discarded, how will this affect how will this hand's score be affected? Model this using a product in an equation. So if we take away the 4 sets of -2, how are we going to show that? So we're going to be removing a -2 from the set of cards. Will increase the score by 2. Okay? So if we remove all of them, 4 of them, that means we're taking away 4 cards that each of those cards has a value of -2. So in essence, what have we increased our score by? Well, we've increased our score by 8. All right, so what 4 matching cards could be added to those pictured to get the same change in score? Well, if I want to use my additive inverse to cancel these -2s out, well then I would be adding 4 cards. So an increase of 8 because I still need a total of 8. An increase of 8 could come from adding 4 2s to the cards. So that would be 4 times 2 is equal to 8. So seeing how each play affects the score, relate the products that you use to model them. What do you conclude about multiplying integers with the same sign? Well, if this is 8 and this is 8, then we can say that -4 times -2 is equal to 4 times 2, which is equal to 8. So adding a value multiple times has the same effect as removing the opposite value the same number of times. Right, so using conclusions from examples 2 and 3, what can we conclude about multiplying integers? And write a few examples. Okay, so the product of 2 integers is equal to the product of their opposites. Okay, removing 2 -4s, and I'm just using an example, is the same as adding 2 +4s. Okay. Going back to the example, adding 3 -5s is the same as removing 3 5s. So we could say -4 times -5 is the same as 4 times 5. And another example, we could say -2 times 7 is the same as 2 times a -7. Okay, so we could do a couple different examples, but it's the same thing. All right, let's move on to our last page. Or actually, that is our last page. So we are done. And now we have all our notes for practicing. One of the things that you might want to add is just being able to summarize this. So multiplying integers is repeated addition and can be modeled using the integer game. If you have a times b, that is going to be equal to the same as -a times -b. And if you have a times a -b, it is the same as -a times b. All right, we'll see you in class.